Okay, let's continue our system design. So in this part, I'm going to talk some more, you can say, OPS concept, or you can say some principles. So last we discussed all the basics OPS principles like your encapsulation, inheritance, polymorphism, abstractions. Now whenever you are designing multiple objects in your systems, object 1, object 2, object 3, object 4, not subsystem, in your system multiple objects, and might be one object can be interact or talk to another object, maybe this object to this object. So sometime we have to define the relationship between the objects. So let's talk some basics. OPS relationship. What kind of relationship one object have with another? Okay, so these relationship also very important for the system designs. Whenever you are doing the system designs, we have to ensure that whatever the object you are defining, and what kind of relationship these have. And one of the key feature about this relationship, that whenever you are going to design system and making some architectural diagrams, and where you are putting the multiple box or multiple object, and while those objects you have to depict some kind of relationship. Okay, so those relationships generally many relationships. So we are not going to talk each and every relationship, but the core concept while the system designing, that we have to ensure that these relationship as a system designer we should know, because this relationship help our system more modular, flexible and maintainable. Okay, so generally this relationship majorly you can say multiple types, but here mostly we talk about the is a relationship and has a relationship. These are the very important, and there are some other part of relationship, user relationship and associated relationship. So these are the relationship name: is a relationship, has a relationship, and the basic implementation or concept. If you talk about the OPS, what the name would be, that would be the inheritance relationship. Inheritance is one of the key relationship. Similarly, we discussed last. Similarly, composition and the relationship. Aggregation is another relationship. Similarly, dependency, association, similarly generalizations, specializations, many relationship you can say your object, your system can have. Okay, so we as a system designing, while system designing, we should aware these kind of relationship. So because this kind of relationship is very important to ensure that we are implementing, we are delivering our system that can be maintainable and flexible in future to support kind of any change, any kind of defects. Okay, so please be ready to understand, read this relationship. Okay, so let's talk one by one these relationship, and you should understand, because these are the very basic, you can say. Even the maybe later part while system designing, we are going to understand how can depict, make a diagram, make a chart for our system. So maybe UML diagrams we talk at those diagrams, these relationships, inheritance, composition, aggregations. Someone say, hey, this is the kind of one component are related to this component. This is the kind of diagram someone prepare. So what the meaning of this? Okay, so these are the standard UML diagrams. They may be depict inheritance, composition, aggregation, dependency, association, aggregation, generalization, specializations, lots of concepts. So these relationship at that times when you are going to depict, make a diagrams, make UML diagrams of your designs, at that time it's very important. And this Whenever we are making any class diagram or sequence diagram or different kind of diagrams, we going to talk later part. But at that times, these relationships like easy relationship, hygiene relationship, are we have to depict so that our developer, while implementing this code, they should aware, hey, here this two component I'm going to implement inheritance, this two component I'm going to use compositions. What are the benefit of inheritance? What are the drawback? What are the composition? What are the drawback? Something. So this, due to that, we, while studying system designs, we should know these relationships. Okay. Directly, if you talk going to solve any system design problem, might be you are not going to talk this relationship, but complete system designs you should aware. Okay. So let's talk details. So here let's talk about the first kind of inheritance or easy relationship. Already we discuss whenever we have a two object 1 and object 2. Okay. So here you want to make a relationship. Why make a relationship? That means maybe there are a couple of field or couple of behavior they have. I want to access here. Here. So as a inheritance we discuss, inheritance is a property, a process through which one object can inherit the property of another object. Here, whatever the inheritable property might be, all the public field, public behavior or methods can be inherited, or some cases the protected. That's good. So this relationship, sometimes someone say, hey, whatever this method, whatever the variable you want to use in this different subclasses, you can use the inheritance. One of the basic you can say terminology developer use, hey, we already written some code in the specific class or some methods, so let's use in the subclass or another subclass these things. So sometimes some developer use, hey, already existing some code, some methods, I want similar kind of things, let's reuse them. So code reusability, one of the criteria for inheritance. That's good. But only this concept is not valid. Before going to make a relationship between the two classes, please make they are a easy relationship or not. So what do you mean easy relationship? So like here, one can have a shape. So maybe one is the square shape, maybe rectangle shape, maybe triangle shape. So all are the shape kind of a relation. So you can say, hey, your square is a shape, or rectangle is a shape, or triangle is a shape. Even you can say account. So account can be saving account, maybe debit account, maybe credit account. So these are the kind of a relationship, yes, because all the account property should here must be account property, because the saving account also is the saving account, current account also the account giver. The basic behavior of account must be, but there is some additional behavior where we need. So please ensure that we have a kind of easy relationship that you can go. So first, whatever the two objects you are going to make a relationship, let's read carefully. You can say this sub account is a super account or not. So let's here one class, maybe here the animal, and here maybe one object table. So you can say table is an animal. Surely we cannot say. So these two classes, animal and table, generally logically if you write the code, they can allow to inheritance. But as a system designer, we have to ensure that whatever the inheritance we are going to use, they have a kind of easy relationship or not. If be carefully before going to implement inheritance. This is not the only purpose. You can just reuse the code. You are going to design system have some kind of a principle. So whatever the super class and subclass, giving the name and just read, your subclass is a superclass or not. If not, you cannot. Maybe this is an animal and you can say cat. So you can say yes, cat is an animal. So here cat class and animal class may have a relationship. Maybe dog, yes, dog is an animal. So you can inherit it. So here's a table, maybe another class furniture. So you can say yes, table is a furniture. Yeah, this is a relationship. But you cannot say table in relationship with the animal or table relationship with the furniture. So generally, whenever you are going to make use of inheritance from one superclass to the subclass, not the rule just code reusability. No, we have to ensure this have a relationship kind of EJ. Means your superclass and subclass, whatever the name you are given, just read your subclass is a superclass or not. If there is a no make sense, don't use inheritance. And there is some drawback of inheritance. Inheritance is a very tight coupling. Means anything change. Let's example here. Okay. So here let's example. Here we have one superclass, and here I've defined some a behavior, a method, and they have a couple of subclass. This subclass, and this subclass. Okay, they are using my calling a behavior. Maybe they have another subclass. They are using also a. So what happened if I going to modify the behavior or signature of this my a method? So notice this is also break. This is also break. This is also break. This is also break. So relationship, inheritance relationship is make a very tight coupling, tight relationship between the object 1 and object 2. Tight coupling, tight relationship, strong relationship generally avoid in the system. This will break lots of inherited data, inherited object. Okay, so please ensure whenever you are going to make an inheritance relationship, please be read 2 times. This object and this object have a easy relationship or not. You can this is the one house. House is the one superclass, and here I can say bedroom. Yes, bedroom or these are the can be relations, but different things, account, bank, anything you can say. Maybe you have a car, maybe engine, anything. Different kind of object you can take. So whatever the example you are going to take, let's make sure is a relationship exit, then you can go for inheritance. Inheritance is the very strong or a tight relationship. All the components they are going to the make a relationship inheritance, they are tightly coupled. Okay, so please be carefully choose the inheritance relationship, because later part if in the parent class or middle layer of multi-level interface someone going to the change or modified, all the subclasses, all the inherited classes are going to the break, are going to the problems, maybe compiler error, logical problem, lots of problem you can face. So while system designing and you are going to make any kind of relationship, and before choosing inheritance, don't choose inheritance just because the code reusability. No, this is not a rule. This is no thumb rule to code. If one class already have written some behavior and method, I want to use this class, let's do. No, please read the meaning of these two model, and both object have a easy relationship, then we can go easy relationship means inheritance, else don't do. Okay, so all the subclasses, what are the specialized version of superclass can be break. Okay, so these are the thumb rule of the system designs. Prefer to not use inheritance for just for the code reusability. Let's read the model and read the meaning and try to understand both object have a relationship established, then you can go, else don't. Hope it's clear about the inheritance. one of the alternatives. So as we discuss, is a relationship is a, you can say, a very tight relationship, or you can say very strong coupling between the object. This is object 1 and multiple inheritance level object, inheritance level object, inheritance level object, maybe multiple inheritance. Where if something change in a super, all break in the sublayer are different. Due to that, this is a very strong coupling. So what the alternative? What the alternative? This is a loose coupling. Okay, loose. So loose coupling is the Hager relationship in composition. So Hager relation means, let's stick. Sometime your two objects can have a easier relationship or Hager relationship. Let's see, my office has a computer labs. Yes, this is a Hager relationship. Let's see, human being or a student, and this is the pen. Okay, this is the pen object. One is the student object, one is the pen object. So here, two objects, you want to make a relationship. So what is saying? You can say a student is a pen. No, we are not going to use a relationship here. So you can say yes, a student has a pen. So this is the has a relationship. So whenever two objects, let's read carefully what kind of makes sense relationship between the object. This is not just let, hey, make it an inheritance. Whatever the object, nature of the object, here this is the student, this is the pen. So we cannot go inheritance relationship here. We cannot say, hey, student inherit the pen or pen inherit the student. No, because there is no logical make sense, hey, a student is a pen or pen is a student. But this is a surely a student has a pen. This is a relationship, good relationship. So please be ensure that whenever you are going to designing the system and you are making a relationship between that, please use a has a relationship. Okay, like here mention example, car has an engine. Okay, so here you can say car is another object and engine is another object. So car can have an engine, yes, but you cannot say engine is a car or car is a engine. No, we cannot say. So just read the two objects and check this object is a relationship or these two objects has a relationship. And a domain expert or system engineer expert, after reading this, apply this is a rule or has a rule, you can identify, hey, here I am going to use the composition or inheritance. So basic thumb rule, if possible, you can go has a relationship, that means composition. Okay, and if really required inheritance, because this two model have a relationship, let's go to the inheritance. So I'm not say ki has a relationship good or is a relationship good or bad. Both relationship is very, very important, but the different context, different situation. Somewhere is a relationship very powerful, somewhere has a relationship is very powerful. So you as a system designer, these are the tools. These tools you can use depend upon the situation, depend upon the use cases. Okay, but we should know as a system designer, I have this tool, is a relationship and has a relationship. Okay, so let's one has a relationship can have a two kind of things. This is also one of a has a relationship, sometimes known as a part of. It is also has a relationship known as aggregation. So here let's talk. So I'm surely this is a very, very confusing part. Somewhere engineer is it very clear? Is a relationship is a very clear. So inheritance, but has a relationship as a kind of a these are the compositions we talk, and similarly we have one of a aggregation. So both is a part of relationship or has a relationship. Similar kind of relationship means where one container and holding some value. The part of is and or you can say compositions composed. Similarly aggregation is a part of. The both indirectly you can say has a relationship. But so what the difference is? If composition is also has a relationship, aggregation is also has a relationship, sometimes no has a relationship, or container relationship. Both are the same thing. Okay. So question: how when I am going to decide these are the really has a relationship, I'm going to the compositions or aggregation. So here say aggregation is a relationship where one object is composed with a multiple object that contain object can exist independently. What do you mean? So here generally has a relationship with only one object, like here car, you can say car has a engine. Okay, so one car has one engine. This is the very kind of a strong bonding between those objects. Our car cannot work, cannot exist if no engine, no meaning of car. So somehow car has an engine. This relationship is very, you can say very tightly, you can say very strong relationship. So somehow has a also kind of a two variants, strong relationship and weak relationship. So somehow if you are going to put higher relationship and that is very strong, then you can say, hey, this is the has a relationship. But somehow let's car, good example, we have a car and this is the engine. Okay? So surely car has an engine, it's a mix, and this is the very strong bonding or strong, you can say, relationship between the car and engine. Without, because if there is no engine, there is no make sense of car. Car cannot exist or car cannot work, cannot function, you can say. But let's car also have a kind of a wheel, or maybe wheel, or car have a side mirror. So might be one car have a 4 side mirror. Okay, so might be one side mirror are broken, still our car work properly. So also car has a side mirror, or car have a maybe wheel, or car have a lots of part. Okay, so let's get side mirror. If we have a two side mirror, one side mirror somehow break or not exist, even our car is works. So you can say car has a side mirror concept, has a relationship, but the relationship is weak relationship. So whenever you decide has a relationship and can have a two variety, one is your very strong relationship, one is a very weak relationship. So here weak relationship means generally we talk about this multiple object, means here generally list of value, maybe one value, two value, three value. So here relationship car have a one-to-one relationship. Might be here one car can have a relationship 0 value, 1 value, 2 value, 3 value, 4 value, maybe list of value, collections of value. And if one exists and not exists, even it works. So let's talk with a code example. Very confusion initial developer feel. So let's say I'm going to write some example. So here let's talk. So here let's talk about like one of a class, your car. Car is a class, one class, and we have another class maybe engine. Okay, another class. So here first there are two relations. So notice, is it way in the let's have one more. So you can say car is a engine, or engine is a car. So here I'm not going to use inheritance. So in the Java language, for inheritance already have a word extend keywords, but for composition there is no any specific syntax provided in the Java language. Let's say here my so here class maybe save, and maybe here class maybe drop the drop function. Okay, void. abstract. Okay. And now here I am going to say rectangle. Okay. So rectangle can be, so here rectangle extend shape means extend means in a Java language inheritance. Okay. Similarly, maybe class triangle. Okay. Triangle extends shape. Okay. Override. Okay. Drawing. Right. Okay. So this is the way. So here in the Java, we have an option for the inheritance extend keyword. Means ki shape, you can say rectangle is the shape, yes. Triangle is the shape. The easier relationship means extend. This is good. But in a Java language, there is no any composition kind of words. So how we can implement composition in Java? So simple composition means container. Has a relationship means car. You can say has a means just engine. So this is the way you can say, hey, car has an engine. Okay. This is the relationship. So this is known as a your car has a engine. This is the composition. There is no any specific word. But now someone say, hey, let's comment out. So here say we can create the car equal to new car. Okay. So, and just print. So notice this is the car created, but I'm not associating any engine, no engine. So logically here I'm able to create car, but without engine. You print out here, it will print, which means they can create the car object, but it's not make sense. Hey, our system allowed to create car without any kind of engine, because car cannot work properly until you have not specified the engine. So as a writing code, we have to ensure this car class have a relationship engine, but while constructing the object, someone must ensure that they are associated some engine. Without engine, car object cannot be created. So how to do? Same like a encapsulation. Hey, here say someone going to create the car. A car. Let's take input as a engine. Okay, and here say. So now I am going to say, hey, this is my car. This is my car class. Now car class cannot be created until someone not specify the engine. You have to first create the engine, and here you can just associate engine. So now it's at least value. So now anyone going to the create car, they must specify the engine. So this car has a relationship with the engine, and this is a very, very strong relationship. Car cannot exist, car cannot build, car cannot make without the engine. So you have must set, hey, this is my car. Someone maybe created inside the constructor itself. Maybe I want to make a dynamic car can have a different types of engine, different power engine. So we can associate different. Someone might be write this code inside the constructor itself. So we generally prefer your engine can be injected at the runtime depending upon your engine power. Different power. Maybe we are going to create one car for a specific engine types, one car for a specific engine types. Okay, so these the code whatever I've written here look is the composition. Why? Because your car has a engine. Okay, so generally this should be upright. Okay, and here you can instance. So next engine may be final. Okay. Okay. So next relationship, how make aggregation. Yeah, aggregation also has a relationship. So someone look this code and can say that this is the aggregation relationship or the composition. How someone says there is no any specific Java keyword. So the car and engine have a relationship, has a relationship. This has a relationship is a composition or aggregation. Okay. So here let's similarly we have a one more class like a side mirror. Side mirror. Okay. So we have a one side mirror. So car can have a only one side mirror or two or three or four. Whenever we have a set of or list of value, then you can say, hey, this is a private. We have a set of your side mirror. Side mirrors. Set list. Okay, list or set, you can use anything. Okay, so here now this car again, this car object has a engine. This car has a side mirrors. So here notice the engine is the very important, that must for the car, but side mirror, maybe we have a two side mirror or three side mirror, maybe one is broken, still our car is work, maybe both are available, then we still work. So maybe side mirror can be 0, can be 1, can be 2, still work, but engine must be 1. Without engine we cannot say, hey, car is working properly, car is function. So you can say relationship with the car and engine is a composition, very strong relationship, and car and side mirrors have a relationship but weak relationship, not so strong. If something exists, it's good to have. If not exists, still car working fine. So this is your aggregation relationship and this is your composition. So aggregation means we have a set of or list of objects contained by the container. So somehow this is a container and this is the actual contained object. The contained object may be 1, that means composition, that is really required, and list, you can say somehow aggregator. Aggregator means couple of value, list of values. Okay, so hope this example clear us about this relationship, your compositions and aggregation. So similarly, there are some couple of more relationship that sometimes we are used, like example UJ, a dependency relationship. So dependency is a relationship where one object use the service of another object. Let's example, hey, this is a payment gateway service, and payment gateway can use the banking service because they are going to do payment. Sometime one object are going to use the another service. Okay, so here payment gateway is the service of the banking service. So sometimes known as a dependency. A dependency is the like one module, one systems are going to depend on another system, and that is they are going to use. Look like a hey, this payment gateway are going to using the particular third-party services. So sometimes we are going to use this use a relationship as well as. Okay, and last but not least, lots of relationship, many kind of relationship. This object-oriented OOPS principle guidelines, but surely we are not going to discuss everything. But let's talk about the some associated with. So many times there are some cases whenever one class or object are going to make a relationship to each other, but might be not the user relationship, might be not a hazard relationship, might be not a user relationship. Somehow just association, like here is some association relationship where the objects are related to each other but not as a kind of a part of a contained relationship. No, look, good example like a student and teacher. No, the students and teacher is teach to student, students are study from the teacher. So there is no easy relationship can be, but some context both are kind of just association relationship, not kind of a whole container or whole part or ownership kind of thing. There is no ownership, there is no containership kind of thing. So somewhere this is known as your association relationship. Actually, I am not going to discuss each and everything here, but lots of further relationship. Maybe you are going to talk about the quantity of relationship, maybe one-to-one relationship, okay, or one-to-many relationship, maybe 0-to-1 relationship. Lots of kind of relationship also exist between the object. Maybe a generalization and generalization relationship, or maybe a specialization relationship as well as, right? Specialized. Maybe sometime maybe this is the lots of specialization, then go to the generalization form. This is generalization form. Then again go to the generalization form. The generalization, specialization, different kind of relationship. So all are the relationship as a system designer we should aware. But these are the very basic, like easy relationship means inheritance, hazard relationship composition, aggregation, dependency, and your association. Similarly, specialization, this is a specialization form, and this is a generalization form, and cardinality maybe one-to-one relationship, one-to-many relationship, 0-to-1, yeah, 1-to-0, or maybe many-to-many relationship between the object. So all are kind of relationships. Let's you can look them if it's any specifics, but starting point of view as a system designing, you should aware these kind of relationships. This OPS principle or your system designer should aware. Sometime you are going to make a relationship as a very one-to-one relationship, or one-to-many relationship, many-to-many, yes, something different. So please be aware as a system, while the system designing, we have to use proper relationship. If say, hey, there is a composition, so you should aware, hey, this is the way composition developer know, designer know, and easily can be implemented. Okay, you should aware this composition, inheritance, association, dependencies. These are the relationship. So hope this information give you the little bit idea. For the system designing, you should know the OPS principle, as well as you should know the relationship between the objects. These are the easy relationship, hazard relationship, aggregation, part of, associated with. These are the relationship you should know. Okay, thank you. This information might be helpful for you. Thank you for watching this.